Let's now talk about combined and independent events. Let's start by combined events. Combined events, I have the formula for it that says that the probability of A union B is simply equal to the probability of A plus the probability of B minus the probability of A intersection B. These are combined events. Now, let's see what are the mutually exclusive events. Mutually exclusive events, in this case, I have a mutually exclusive event. Exclusive events. As you can see in the mutually exclusive events, events A and event B, they don't intersect. There is no intersection. So in this case, the probability of A intersecting B is always equal to 0. So, since the probability of A intersection B is equal to 0, I have the probability of A union B is simply equal to the probability of A plus the probability of B. It's simple and easy. In the mutually exclusive event, simply I don't have intersection, so the union is equal probability of A plus the probability of B, because the probability of A intersection B is equal to 0. Now, the last thing we'll talk about is the independent events. All what we have to know about the independent events, to prove that any two events are independent, we have to show that the probability of A intersection B is simply equal to the probability of A times the probability of B. And by this, I can prove that any two events are independent. Let's have an example now. In a class of 26 students, 10 study chemistry, 15 study physics, and 5 study neither subjects. We need to find the probability that a student chosen at random study both subjects. In such a case, we always are advised to draw a Venn diagram. So let's start by drawing our Venn diagram. I have this, and I'll be drawing inside 2 circles. One for event A and one for event B. Now, event A are these students who study chemistry. I label it with C. And these are the students who study physics. And this is my universal set. When I want to fill in Venn diagram, I always start by filling the most intersected area. So now we need to find the probability that students study both subjects. Do I know the number of students who study both subjects? No, I don't. So I label it as X. For now, in this area, students who study only chemistry, the total of students who study chemistry are 10. So in this area, who study only chemistry are 10 minus the intersection, which is 10 minus X. And I repeat the same process for physics. All of students who study physics are 15. So who study physics only are 15 minus x. And students who study neither subjects, which are outside, are 5. Now, in order to find out the value of x, I simply need to add up all these values inside and make them equal to 26. So I have 10 minus x plus 15 minus x plus 5 simply equal to 26. Simple addition now. This minus x will cross out with this x. I'll end up having 10 plus 15, 25. This is 30 minus x is equal to 26. So the value of x is equal to 4. Now, since I know x is equal to 4, I can substitute in my fields. This value is 4. So this value will be 6. And this value, 15 minus 4, would be 11. Now let's find our probability. We need to find the probability that student chosen at random study both subjects. So the probability to study both subjects is simply equal to this value, which is 4 over the total. So study both subjects is simply 4 over the total number of students, which is 26. By this, I could find out the probability of a student studying both subjects by first drawing a Venn diagram, figuring out the right values in each right place, and then I found out the probability that I needed.